Well, folks, it just might be the year of Linux on the Commodore 64. Well, not quite, but with the SISOP 64 FPGA cartridge, you get an ARM coprocessor running full Linux. Let's take a look at the ways you can access the Linux side and make use of its capabilities. SISOP 64 uses the same IceVic video core, but in this case, it's generating HDMI video at 1080p. You don't need Linux at all for this basic capability, as it's part of the FPGA core. There are multiple ways to access Linux. SISOP 64 includes a console terminal application that overlays a Linux shell on the Commodore 64's video. If you connect your SISOP 64 to your network, you can also use SSH. Let's look at the console terminal. In this video, I have button number 3 configured to launch the console terminal. When this happens, DMA is enabled and the terminal shell is able to read the Commodore 64 keyboard. Let's try a few commands. As you can see, the DE10-Nano is running Debian 12. We've got plenty of storage on the SD card for all the games, demos, and applications you want. Of course, we also have access to the network for essentially unlimited storage. Program loading uses DMA, and most loads are nearly instantaneous. By the way, this is a great demo by LFT called 9. If you haven't seen it yet, be sure and check it out. I've got button number 2 configured to launch a custom menu application. Here's what it looks like so far. This one is code running on the Linux side that takes over the display. It asserts DMA, which effectively freezes the Commodore 64 while allowing us to read the keyboard. If you hit the button again, it goes back to the running program. Let's use this menu to load something else. How about another demo? Let's try Oldies and Goldies by IPC. This demo was another fun test case I used when developing the IceVic video core running on the FPGA. If you connect a USB keyboard, you can also open the console without impacting the running program. Hit Control plus the tilde key to open the console in this way. And, of course, you can always just SSH to it from another computer as well. If you prefer a different color palette, the SISOP 64 supports changing the colors to whatever you want. You can do this from Linux with the set color command, like this. Just pass the color number followed by the RGB value. If you want to make color changes happen every time the SISOP 64 boots, just edit the user local bin C64 init file like this. With the DE10-Nano, it's easy to reconfigure the PLL from Linux. That means we can adjust the video clock timing from software, so most users will not need to manually adjust their C64's clock setting like on the IceVic. Use the video info tool to show the current timing information. Then run PLL config to recalculate settings and program the PLL. This happens automatically in the startup init script every time the SISOP 64 boots. Let's take a look at a super simple example of writing a program to run on Linux to drive the C64. This one is written in C. Start by calling SISOP init. Then we connect to the DMA broker, which is used to ensure only one process has DMA access at a time. We request exclusive access with SISOP DMA lock. Then we just poke values, in this case to write some characters to the screen. Before exiting, we uninitialize everything. We'll compile using our makefile and GCC. To run it, just execute like you would any other Linux binary. And there you go, your first Commodore 64 DMA program running on Linux. Next, we'll look at raster line handling. There are a few ways to do this. In this example, once per frame, we queue commands to the DMA FIFO. You can wait for any raster line character combination. After waiting for just the right moment, you can poke any address you want. Now, this part is super important. Since we're now looping infinitely, we need to make sure that when the program is terminated that we shut down gracefully. We do that with a typical SIG-int handler that contains our uninitialization steps. There you have it. We have changed the background and foreground colors at a specific line. This simple technique can be used for all kinds of cool demos and effects. Let's look at a few more. First, we'll reset the machine. The CMD program on Linux provides a way to issue commands to the FPGA. CMD0 is used to reset. The dancing animation you've seen in my other videos is another example of a Linux program using DMA to drive the C64. It's just raster line timing for color changes, plus transferring data into the machine's address space during vertical blanking. There are 10 megabytes of bitmaps here. This simple demo would be very difficult on a stock Commodore 64, but is easy when using the SISOP 64. I look forward to seeing what others are able to do with this. In this video, we've just scratched the surface of what's possible. Having Linux in a cartridge with DMA access and a shared frame buffer, massive storage, and network capability all make for some exciting new possibilities for the Commodore 64. In upcoming videos, we'll look at how interrupts can be used to signal between the C64 side and Linux. Don't forget, please like this video and subscribe to show your support for this project. Thanks for watching. See you next time.